test again here. So what was it? It was comparing population means. And we did confidence intervals. And hypothesis test for that. And then we did population proportion. And likewise, we did confidence intervals and hypothesis test. And then we did chi-square test. We did goodness of fit. Right, that's when we had one variable and we were comparing data to what we expect, right? Goodness of fit, comparing data to what we expect. And then we had chi-square test for independence of two variables. That was the contingency table. And then we did regression. So we did linear relationships. And linear regression, we did the coefficient of determination and the correlation, right? Correlation, R squared. Okay, so that's what we got for the exam. So you've got to keep this stuff straight, right? Because so many of it has to, there's things that have to do with confidence intervals and hypothesis tests that, hypothesis test is running through the whole thing. So when you come to a problem, you have to identify what kind of problem it is, right? Because you have to have that straight in your mind. If you're approaching a problem and you're thinking of the wrong type of problem, well, you're never gonna succeed at it. Okay. So let's work on. So we have time for the blue sheet. Let's do this one together. So we're asking the question, are the means the same? We're asking the question, are the means the same? And we're going to do a hypothesis test of that and then a confidence interval. So to see if they're the same, we're going to use t-stat, 2 sample. And this time we were given the summary. You're given the mean, standard deviation, etc. So you're going to do t-stat, 2 sample with summary. Okay, sample mean number 1 is 15668.5. Standard deviation is, so this is the guys, right? This is the guys. So the data that we got said that the guys spoke 15,668 an average words per day or something. And that was 50 guys. All right, then the girls, 16,215 on average words with a standard deviation of 7301.2. Sample size there was 56. So we're asking the question, do men and women speak a different number of words? Do they or not? No. So yeah, so obviously the means are different. You would not expect the mean to be exactly the same for men and women, whether they speak a different amount or not. It would be incredibly coincidental if you got the exact same mean. So that's why it's like a gray area, right? So they're different, but are they different enough to suggest that men and women truly talk different amounts? Okay, that's what we're asking. So we're doing a hypothesis test, and it just says, is it different, right? Is it different? So we want this one, where mu1 minus mu2 is 0, versus our alternative that it's different from 0. So we're just saying, is mu1 different than mu2? So we compute, and what are we interested in? We're interested in test statistic. Okay, our test statistic, negative 3.49. Okay, so we're going to have right. We have our distribution curve here. What is our variable in these problems? It's a single variable. Even though we're comparing two populations, we have a single variable. And what is that single variable? No, it's the difference of men minus women. That's what the variable is. It's the difference. If we're going to compare the two, then it's like comparing the difference to 0 or non-zero. So the variable is the difference between the two. That's what this says right here. See? The null hypothesis is the difference of means is 0 versus the difference of means is not 0. That's the variable. Okay? So what do we get? We got a t-stat of negative 0.35 basically. So where's that? So the difference of 0, so this is a difference of 0 in our hypothesis test. So we got a difference of negative 0.35. Now we got to figure out, is that in the rejection region or non-rejection region? So we need our test statistics. So that's from the T table. And it says use how many degrees of freedom? 49 degrees of freedom. And now this is a two-tailed, let's do this second. Let's get the region first. So it's a two-tailed test. That means how much area is on either side? 5%. And in the T table, that's what you're going to use, right? Because the T table gives you just the area on one side, right? Is that what the picture shows? So this has got to be 0.05. And this is going to be 0.05. So our test statistic, our critical value is actually going to be a plus or minus. We're going to have the critical value there and there. So 49 degrees of freedom and alpha over 2 of 0.05 is what? 1.6768. Now that's a plus or minus because it's a two-tailed test. We also have this one down here, negative 1.68. If it was a left-tailed test, you would get this positive number out of the table, but you would be looking at the negative number, right? You would take the negative because it's a left-tailed test. Since it's two-tailed, we have it on either side. So there's our rejection region. Okay, so this is what? This is number of standard deviations on our variable. And our variable is the difference of the means. The variable is the difference of the means. Okay, so what was our test statistic? Negative 0.35 right here. Reject or don't reject? Don't reject. Because there is evidence or there's not enough evidence? Not enough evidence to say that men and women speak different amounts. Okay? So yes, in this sample, women spoke a little bit more than the men. And that's what we would expect. We wouldn't expect them their average number of words to be exactly the same. That's just like, it'd be like winning the lottery, right? But they're not enough different. They're not enough different. We got a test Wednesday, right? Okay. They're not enough different to say that the samples weren't enough different to say conclusively or at a 10% significance level that men and women speak a different amount. Doesn't make sense. Not enough evidence to conclude that men and women speak a different amount. Okay, so then does the confidence interval back that up? So now let's do the confidence interval. So the confidence interval, we go back to that same place, but instead of the hypothesis test, we're going to click on confidence interval. And what was the confidence interval we wanted? 90, change it to 0.90. And we're going to compute. Okay, so the center of the confidence interval is going to be, the best information we have is that women speak on average 500 more words a day. So that's why the center of the confidence interval will be negative 546.5. Confidence interval is based on the data, right? It's based on the data, and the data said on the average women spoke 500 more words a day. And then the upper limit would be that men speak 2,000 more words per day, 2048, and that women speak 3,000 more words per day. So 3142 and 2049. Negative 3142. What is that? That's saying that the left end of our confidence interval is that women speak 3,142 more words per day. The right end says that men speak 2,049 more words per day. And according to our data, women spoke 546 more words per day. But we can be what? We can be 90% confident that the difference of the means falls in here. So, yeah.
Just to make sure I understand this correctly, what you're doing here is you're just taking the t statistic, whatever, and then using like actual numbers now that directly correlate with that.
No, this has nothing to do with the t statistic. This is a confidence interval. Oh, I guess it's based on the t. Yeah, based on t.
I just wonder if it's directly correlated.
What's that?
It's directly correlated from the graph that we had just done previously.
No, I went back and I did confidence interval. Remember? So I went back to options edit here. And instead of doing the hypothesis test, now I'm doing the confidence interval. Okay? It's also based on t-scores, right? So it's also based on t-scores, but it's a separate thing. So is this consistent, the fact that we're 90% confident that the difference between the means is from negative 3142 to 2048, 2049? Is that consistent with rejecting the null hypothesis? By rejecting, we're saying that we can't say that men and women speak a different number of words. There's not enough evidence for that. So does this confidence interval back up that conclusion? And how? If it does, how? What does this say again? What does negative 3142 mean? Women speak. So this is the lower end of our confidence interval. This is we'd be 90% confident that the difference between the number of words spoken is between negative 3142, meaning women speak 3142 more words per day, until the difference of the means is 2049, meaning men speak 2,000 more words per day. So is that interval consistent with rejecting or not rejecting the null and saying we don't have evidence to say that one speaks more than the other? Yeah, but look at the interval. It's all the way from that women speaking 3,000 more to men speaking 2,000 more. We're 90% confident that it falls in here. So it's very possible that the mean is up here at 1,000. Men is speaking 1,000 words more. Men speaking 1,500 more. It's in their confidence interval. So there's lots of room in the confidence interval saying that men speak more words, right? There's a big chunk of the confidence interval saying that men speak more. So could you conclude that men men speak more or women speak more from this confidence interval? No, there's a huge part of the confidence interval that would suggest that men speak more. And also, but then, of course, there's the part that suggests women speak more. So from the confidence interval, you could never conclude, oh, yeah, definitely women speak more or men speak more. And that's also what we said here. We did not reject the null hypothesis. If your confidence interval was all in the negatives, say your confidence interval was from negative 8,000 to negative 2,000, then what could you conclude? So if it was from like negative 8,000 to negative 2,000 was your confidence interval, would that be consistent with not rejecting the null? What would that mean? The confidence interval from negative 8,000 to negative 2,000. We'd be 90% confident that women speak more, right? Because all in the 90% confidence interval, 90% confident, we get a negative value, and that's women speaking more. So that would be a confidence interval that would definitely suggest that women speak more. But we've got all these positive numbers in our confidence interval that would suggest men speak more, so that you cannot conclude one or the other from this confidence interval, and that was the same thing we figured out there. Does it make sense? Well, you'd be that percent sure. You'd be that percent sure that men speak more within that interval. You see? Okay, let's move on to the blue sheet for time's sake. So on the white sheet, go ahead. So turn the white sheet over first of all. If you want to practice, number 1 is good practice, but cross off number 2. Just put an X through number 2 on the back of the white sheet. And then the difference between number 1 here now is that you're actually given the data. It's not the data summary, you actually have the data. So you have to use StatCrunch a little differently for that one, you see? Instead of being given the mean and standard deviation of each group, now you have the actual data values. So it's not going to be with summary, it's going to be with data when you use StatCrunch. Okay, let's go on to the blue sheet. This one? All right, so in StatCrunch, so what is our null and what's our null and the null hypothesis is what? Yep, that that 60% of people prefer chocolate ice cream. So 0.6, right? And the alternative hypothesis is what? More than 60%. Okay, so we're going to go into proportion stats. And what do we have? One sample. And we have data or summary? Summary. How many successes? 667. Observations. And then we want a hypothesis test. And our null hypothesis is that it's 60%. And the alternative is it's greater. So that's what we set up. So P equals 0.6. P is greater than 0.6. We got, this is the actual data. And then we'll compute it. And we get a z-stat of 1.48. So that's going to be what we're going to use to see if it's in the rejection region or not. So let's get our rejection region. So for population proportion, we use the z-test, right? And if we're doing if we're doing greater than, that's a one-tailed test to the right. So we need our critical value. And so what is this area going to be? 5%. We don't divide by 2 because it's a one-tailed test. So 5%, but your z-table tells you what areas? To the left. So you're going to look at a z-table for this area being what? 95%. So you look in the z-table at 95%, and that gives you a critical value of 1.645. Does it make sense? So, reject or don't reject? Do not reject. 1.48 is here. We're in the non-rejection region. Do not reject. Meaning that what? What's the conclusion? There is evidence or there's not enough evidence? Not enough evidence to conclude what? There's not enough evidence to conclude that more than 60% of people like chocolate ice cream. It could very well be 60%. That's our conclusion. It very possibly is 60%. Although our data gave us a little bit greater than 60%, it wasn't enough greater than 60% to say conclusively that more than 60% of people prefer chocolate ice cream. Okay, so here's the game plan.